Hi, in this video I will show you how to create a simple AI agent that helps with Jira reporting. It focuses on analyzing ticket cycle times, but you can apply the same approach to explore any Jira data or other products data. This is just an example of how you can create your own analytics tool targeted towards your needs. Here is what we will cover. First, a live demo of the agent in action. Then, how it works behind the scenes. Finally, another execution that will hopefully be clearer after you understand the agent better. Now, what's the actual problem we are solving with this agent? In Jira projects, you often need to answer questions like, where are tickets getting stuck in our workflow? How long do tickets spend in each status? Which transitions are bottlenecks? Are there any patterns? Jira has built-in reports, but they're limited and it's not easy to explore different epics, time periods, or ticket combinations. Imagine if you could just ask, analyze the status flow of my tickets. That's what this agent does. Let's see how it works. I will start by asking for a subset of tickets which I'd like to analyze. For example, give me the tickets in project Sky which are in progress and the links to them. I'm doing this demo on my personal Jira instance where there is not so much data, but should be just enough for you to follow. And here I am forwarded through the MCP server authorization. I have to approve that the MCP server has connection to my Jira instance. Let's do that and return back to the agent. The agent responds with a list of tickets. Let's take a look at how my project Sky looks for you. This is my board and there are 6 tickets altogether, which are currently in status in progress. And one of them is in fact an epic. Returning back to the agent, I'd like to analyze those tickets and I will just simply say analyze these tickets. The agent is asking me how I'd like to analyze them, and it offers the option to create a Sankey diagram, and it also tells me that there are 2 more options for visualizations. I will ask for a Sankey diagram. And let's take a look at the diagram it created. What this Sankey diagram reflects is the transitions through which the tickets went. The flow lines indicate how long a ticket stayed in a given status before it transitioned to the next one. The thickness of the line represents the total number of days tickets stayed in that status. In this case, in the backlog status before moving to in progress. The thicker the line, the more days tickets stayed in this status, and vice versa. Thin lines indicate that tickets move through a state very quickly. Let's now ask for a histogram. It is asking me for which status I would like to get the histogram. I'd like to have it for in progress. And here is our histogram. It shows the distribution of how many days a ticket stays in this status, so you can monitor how the majority of tickets perform and if there are any patterns. As you can see, the agent also tells us that there is a bottleneck warning. 100% of tickets are very slow because obviously my tickets, most of them stayed in progress status for 20 days to 22 days and some even beyond 30 plus days. Before diving into how this agent works, it's important to reflect that when building any automation, AI or otherwise, the knowledge of how to optimize and create the right architecture is far more valuable than mastering a specific tool or framework. And AI isn't always the most efficient choice, even when it seems like the obvious one. So let your goal and constraints determine your solution. Let's take a look at the agent. I'm using a single Google ADK agent with a set of local tools and remote tools exposed through the Atlassian MCP server. The agent first retrieves the set of tickets requested by the user using a remote MCP tool. The agent decides on its own which tool to use, and for getting Jira tickets, it likely calls the Jira search tool. Then it calls the Get Jira Ticket Status Transitions tool. It's a local tool which it uses to fetch the changelog for each ticket and extract the status transitions from it. The result from the extraction are triples holding information from status to status and days in status. These are stored in the agent's tool context argument, so they are available later when analysis and visualizations are needed. After the status transition data is extracted and stored, the agent uses the given visualization tools to aggregate the data and generate diagrams. The data is prepared separately within each visualization tool, as these tools require different schemas. There are also two helper tools, it's just one here on the picture, that enable user to start an analysis of a fresh dataset, which would discard the previously analyzed data. So the agent can clear the previous dataset using this Clear Status Transitions dataset tool. While building this agent, I needed to take some decisions. At first glance, this automation seems very easy and straightforward, and while working on it, I was tempted to let the LLM do most of the job, like extract status transitions, identify changes, and calculate time spent in each status. Why did this seem like a good idea? Because changelog data is messy. There are a lot of fields, complex nesting, and an LLM can handle that variability. But using an LLM resulted in added latency and costs because every ticket processing required an LLM call. LLMs are also not reliable at doing calculations, and I realized that I was using AI to parse already structured data. And I did try this approach and it showed all its flaws. Therefore, I reverted to using the Jira Python library to fetch changelogs and parse them directly with code. The LLM is still valuable in the agent for understanding user intent and deciding which tool to call. Now, let's look at the agent instructions. I've given this agent a go. It helps users analyze Jira tickets, and it has a very loosely defined workflow. It first analyzes the user's question to determine their specific intent, and it always offers the user to clean the dataset in case the agent has already processed one or more datasets. So the user can either start with a fresh dataset, fresh data, or they can add to the existing data. And then the agent is instructed to always first offer a Sankey diagram for the status transitions, so the user can see how the tickets went from one status to another, and then it offers also to the user to provide or to create a histogram or a bar chart. And yeah, with that, maybe let's try to ask the agent for another set of tickets so we can analyze them. For example, I have an epic which has some more tickets in it. Let's try analyzing this epic and seeing how the agent works. Give me the ticket in epic which is called Sky 550. Now I got those, and we can see that the agent is asking, I have existing data from previously analyzed tickets. Should I clear the data before analyzing these new tickets or add to the existing analysis? Clear. And start fresh. So I am telling it to clear the existing data and start fresh analysis. Let's take a look. It cleared 18 transitions and is getting the data for 9 tickets. And again, it asks which type of visualization I'd like to get. I'd like to have again a Sankey diagram, and then I will ask for a bar chart and a histogram. We can see that the transitions of the tickets in my Jira Epic look differently. They are most of them stayed a long time in the backlog, and then some of them are currently selected for development, some are still in the backlog, and some are still in progress. This is just a test data, so it's not very representative. It would be great if I had a production Jira to try this agent on. Let's ask, for example, for a bar chart. We can see the total number of days of the tickets in this epic stayed in progress, and here we can see the total number of days they stayed in selected for development. I have excluded the start and end statuses because they don't matter much. For example, we don't want to analyze how long a ticket stayed in closed status after it has been closed. Let's take a look at a histogram. The agent is again asking me for which status I'd like to have it in progress. And here is our histogram. Most of the tickets again stayed roughly around 20-22 days in progress, and 2 went through in progress very quickly. Some of these tickets overlap with the tickets from my first data set. This is why we see similar data here. And with that, the demo of this agent is finished. You can find the GitHub repository and the code for it in the description below this video. Thank you for watching.